Hey guys, if you have any doubts regarding class 12 physics, chemistry and maths, you can send message to me at the email ID given in the description box. Now let's see moment of inertia derivation. So first, this is the derivation of moment of inertia or angular mass or rotational inertia. Then this is the diagram for the body of n particles. This moment of inertia is the general form. Other In the next derivation we are going to see the moment of inertia of a uniform disk. So first, in general, we can see this is a rigid body which is rotating at the angular speed. Consider n number of particles consisting of mass m1, m2 and so on, with the respective radii r1, r2 and so on. So as you know, V is equals to R omega. So V1 is equals to R1 omega, V2 is equals to R2 omega. Since omega is constant, we are going to write omega only, not omega 1, omega 2. So if we see the translational Ke of the first particle, it is Ke1 is equals to half m1 v1 square is equals to m1 r1 square and omega square. Similarly, you can write this for Ke2, Ke3, Ken and so on. Like this. So if you want rotational Ke, the rotational Ke you will get by adding all the linear Kes. So this is, then half you are going to take common m1 r1 square plus m2 r2 square plus dot dot mn rn square. Omega square will be also common, which we have written here. You can write this here also. And all this you will get I, where I is this. Okay. So you will get the rotational Ke as half I omega square. If you represent the I as this, you replace mass and angular speed, omega replaces linear speed. So rotational Ke is half I omega square and translational Ke is half mv square. This is replaced by this and this is replaced by this. So here the definition of this. Now the next derivation is moment of inertia of a uniform disk. This is a diagram. There are so many small rings here. By combining all the small rings, you will get the whole disk. So consider one such disk. You are going to consider the mass of small disk as dm and thickness dr and radius as small r. So the moment of inertia for this small ring is di dm r square. Okay, and if you consider the whole disk, then mass per unit area is sigma m pi r square. And if you want m from this, then sigma pi r square. This capital R is for the whole disk and the small r is for the small ring. Okay, so if mass of infinite small ring will be, this m will get replaced with small m and this r will get replaced with small r. Now guys, if you are a mathematics student, you are aware of the derivatives chapter. So you are going to differentiate this with respect to r. So dm upon dr, sigma and pi are constant, so it will be outside, and d by dr of r square. So if you want to take the derivative of r square, it will be 2r. So dm upon dr is equals to sigma pi 2r. dm is equals to sigma pi 2r. This dr will go there. You are going to substitute the value of sigma, which is m pi r square. This pi and 2r dr remains the same. So here pi and pi gets cancelled. dm is equals to 2m r square r dr. Okay, till this. For the students who have not taken mathematics, I'll explain you what is derivative. Whenever you take derivative, the number here comes here and you are going to subtract that number from 1. Okay, if it was r cube, then 3 will came here and 3r, 3 minus 1 2. Okay, now let's continue with the derivation. Okay, we had stopped here. Now we want the di. So moment of inertia is what? Mr square. So here you're going to write di because we are taking off the ring. So di, d represents the small, and dm r square. And what you got dn, you're going to write here. This r square remains here. So 2m r square, this r and r square will be r cube. Okay, this is the moment of inertia of the small ring. We have to remove the moment of inertia for the whole disk. So now for the moment of inertia of the entire disk, you are going to integrate, which again is a part of maths. So I is equals to this. For whole I, you have to integrate the small di. So this is the sign of integration. So when you integrate, you have a definite integrals from 0 to capital R, and this 2m r square r cube dr. Okay, now you have to see this. If it is small r, you are going to integrate only that small r. This will be constant, which will come out of the integration sign. 2m r square will come outside the integration sign, and only r cube will remain here. Now this is a reverse of derivative part. For derivative, what you take 3 here and 3 r square. But for integration, it is the opposite. You are going to add 1 to here and also upon to that addition. So it will be r raised to 4 upon 4. This integration sign will go into bracket and this value will remain here. Now you have to substitute this value over here. So r raised to 4 upon 4 minus, in between these two values will be subtraction sign, 0 raised to 4, 4. So this is the outside part. This will be ignored. So this will be remain. Cancellation part, mr square upon 2. That means the moment of inertia for the uniform disk is half mr square. Thank you.